Okay, so let's do it if it's an equilateral triangle. Again, thank you, boys and girls, for not talking while I'm talking. All right, so do we want to do perpendicular to the x-axis or to the y-axis? Well, let's just do to the y. Let's do perpendicular to the y-axis. So I'm going to draw an equilateral triangle. The base would be here. And it would look like that, coming out. So you have to imagine that sticking up, if you will. All right, so if I'm doing it with perpendicular to the y-axis, I need to solve for x in terms of y. So what would this be, x in terms of y? Yeah, plus or minus. Okay, so what is the area of an equilateral triangle? That is something that you need to know. Does anybody know what that is? That's the formula you need to know. It's going to make your life easier if you remember that the area of an equilateral triangle is radical 3 over 4 s squared. Okay? What? In geometry? But you can prove it using Pythagorean theorem if you like, right, Wyatt? Okay. All right, so now that we have the area formula, we need to figure out what is S. How do we find S? Well, in our previous problem, even though we were doing it with the x-axis, the distance from here to here would be what? What's that distance? And so the distance from here to here would be what? So what is the total distance? What's the total length of that base? Very good. Did everybody understand that? Everybody gets that? So then our volume is going to be the integral from what to what? -1 to 1, and it's going to be radical 3 over 4 times s squared, where s is 2 square root of 1 minus y squared, quantity squared. dy, thank you. No, we don't need pi, only if it's a semicircle or a quarter circle. That's the only time we're going to need pi. This is fattening. So then we can simplify that, and this is -1 to 1. We can bring out the radical 3 over 4, and this becomes 4 times 1 minus y squared. You want to bring out the 4 as well? Bring out the 4, they cancel, so I have radical 3, the integral of -1 to 1, 1 minus y squared, dy. Anything else we can use to make our life easier if we had to do this by hand? What else could we use to make our life easier? We can use symmetry because this is symmetrical, so I can do 2 radical 3, the integral from 0 to 1 of 1 minus y squared, dy. Okay? So that's a lot easier to integrate than what we started with. And your answer's in your notes, so what is the answer? 4 root 3 over 3. Okay? How are we doing? Okay, so this one we actually have to do, it tells us that our y-axis, this is perpendicular to the y-axis here. And once again, we're doing equilateral triangles. So if I were to draw that triangle, I'm going to have, let me use a different color since that's already, we can use red. We could be nice and holiday-ish. Okay? So we've sort of done this already. We know that the area of an equilateral triangle is what? What's the area of an equilateral triangle? I just told you. 3 over 4 s squared. And what would be the length of S? Okay, I need to solve this equation in terms of y. So what would what is x equal to? Square root of 8y. So my length, so what is this length? Plus or minus root 8y. So what is this length? It's what? What's the entire length of the base? 2 square root of 8y. Does everybody understand why it's 2 square root of 8y? Yes? So now we just plug it in. So our area is equal to radical 3 over 4 s, which would be 2 root 8y squared. And so my volume is going to be, okay, we can take out the root 3, 4, and we can take out the 4 here. Can I skip both of those steps and get the integral of just 8y? And what am I integrating from? Okay, how did you get 0 to 4? Okay, because we're bounding it by 4, so we're going from 0 to 4. Did everybody get that? Yes? Okay. And the answer's on there. What is the answer? Oh, it's multiple choice? So you don't have an answer? You want one? All righty. So we can take out the 8 as well. So we get 8 root 3 from 0 to 4 of y, dy, and that would be y squared over 2, integrated from 0 to 4, which would be 16/8 times 8 radical 3. Is 24 radical 3 a choice? How did I get, 8 times 8 is 64. It is, isn't it? So 64 root 3. Okay? Are we good? Yes? Ooh, this is fun. This has an isosceles, let me